Alright, so this is the first video in M439. It's accelerated trig calc A. So the first semester is all trigonometry, and then we get into calculus for the second semester. Alright, so I'm going to try and put these online for all the chapters. Maybe not everyone, but I'm going to be working on getting them all on here. So this is basically, the first one is chapter 1 of trig. So this is day 1. This is all, a lot of this is review from geometry back in 218. Okay, so the first thing, just something really basic, just to keep your mind, get your mind started here. We're going to talk about our quadrants. And remember, this is quadrant 1, 2, 3, and 4. And how do you remember that? Well, it's easy to remember that is we are the Kona Cougars. So the C starts here and it goes over there. So this is, 1 here, 2 here, 3 here, and 4 here. Right? Pretty easy. Now, if you're at Schaumburg, that would be really difficult. The Schaumburg goes like this. They go 1, 2, 4, 3. Frem starts at 2, goes to 3, goes to 2, back to 1, 3, and 4. It's just very complicated. Hoffman, 2, 3, 1, 4, and then somewhere on the x-axis. And then, of course, Palatine is 2, 3, back to 2, 1, and then x-axis. Okay, very complicated. So Kona is the only easy one with the C. All right? That's pretty convenient. All right. So let's talk about the distance formula now. Remember, the distance formula is used to find the distance between 2 points. All right, so of course we have x1, y1, and x2, y2. And the distance formula is this: d equals x2 minus x1 squared plus y2 minus y1 squared. All right, this actually is derived from Pythagorean theorem, right? You guys should know that, right? D is really your distance between, so that's C, that's your hypotenuse. And then a squared is the difference between the x's, and b squared is just the difference between the y's. Okay, and then you square those. All right, now sometimes people get confused to memorize that, the distance formula, and they get kind of confused with that minus and that plus and that minus. So I always say the distance formula is a sassy formula. And SASSY stands for subtract, add, subtract. Right there, man. So it's a sassy formula. All right, so that's good, kind of a good way to remember that. All right, so let's actually do a problem here. We get negative 3, 2 root 5. Oops, 2 root 5. And negative 2, negative 3 root 5. So we have our distance equals, and now I'll tell you, if I were you guys, I would set up the parentheses first, put the plus sign, the 2 minus signs in between, and now plug everything in. Because what happens is you got so many negative signs, and it's really easy to forget one if you got a bunch of negatives and you're already subtracting. All right, so you put it in there, and life is going to be a lot better. So we're going to put negative 3 and negative 2. It doesn't matter which one you do first, right? Because if you're finding the distance between x2 and x1, or x1 and x2, it doesn't really matter. Okay, it'll all work out in the wash anyway, because when you square it, it becomes positive anyway. All right, so and then we're going to do 2 root 5 and then negative 3 root 5. Okay, so the distance equals, that's going to be plus, so it's negative 1 squared, and that's going to be plus, so plus 5 root 5 squared. So it's the square root of 1 plus, right, 5 root 5 squared, it's 5 squared is 25. 25 times 5 is 125. So it's equal to the square root of 126. And then you see numbers that can go into that. 9 actually goes into that. So you can square root of 9 is 3. And you have 14 left over. Okay, pretty easy schmeezy. All right, let's try, let's actually do a problem using the distance formula. All right, so I'm going to give you guys x, 7 and 2, 3. I'm going to tell you the distance is equal to 5. And my first question is, how many answers am I going to have? Okay, it might just have one answer because it's, one distance from something comma 7 to 2 comma 3, and that's only one distance that's 5. Well, let's think about it. So I'll put that question down here. How many answers? Okay. So let's plug it in here. 5 equals the square root of, and let's again put it's sassy, subtract, add, subtract. So x2. So we're gonna make this x, the first one x2, just to make it a little bit easier. It's x minus 2 squared and 7 minus 3 squared. So 5 equals the square root of x minus 2 squared. 7 minus 3 is 4. 4 squared is 16. How do you solve for x? You square both sides. So we get 25 equals x minus 2 squared plus 16. Subtract 16 from both sides, you get x minus 2 squared equals 9. Take the square root of both sides, and x minus 2 equals 3, right? Boo! Plus or minus 3. Okay, you can't forget that. And then we're going to add 2 to both sides. So we get x equals 2 plus or minus 3. So x is 5 and negative 1. Aha! 2 answers. How do you get 2 answers? Well, if I actually would sketch this, 2 comma 3. It's right here. That's our starting point. And it's x comma 7. So it's going to be 5 comma 7. That's 3, 4, 5, 6, 7. So 5 comma 7 and negative 1 comma 7. Well, of course there are 2 answers because they're two distances. Right? These distances are the same. It's, I can draw a triangle here, and that happens to be a nice isosceles triangle. All right? So that's why you can have 2 answers. All right, that looks pretty reasonable. All right, so let's talk about special, very special, right triangles. All right, and you guys remember how, some of the special right triangles, remember they're called Pythagorean triples. And we know a couple of them. I'll just list a few of them. 3, 4, 5. And, there's 5, 12, 13. I'm sure you can name lots of others. How do you verify? How to verify? Well, of course, you use a squared plus b squared equals c squared, with c being the longest side, or the hypotenuse. Okay, that's pretty mellow. All right, let's talk another thing here. It's called interval notation. You will see that a lot in trig, and you'll also see that a lot in calculus next semester. All right, so real quickly, x is between 2 and 4. Okay, notice this is a less than or equal to. So that is a bracket, okay? And a less than symbol, that is a parenthesis. So the way I write this one is, it's between 2 and 4, just like that. All right? Now if I want to say x is greater than 2, well, that's going to go from 2 to infinity. Notice this is a parenthesis, and notice that's a parenthesis too, because you never get to infinity, right? Infinity, everyone always thinks infinity is a number, and infinity is not a number. It's you approach infinity. You can never get there. Well, I've been there like 2 or 3 times, but most people you just can't get there. Okay, it's just something that you approach. That's why infinity is always with a parenthesis. And then x is less than or equal to 3. Well, that means it's negative infinity to 3. Okay, that one's got a bracket because it includes 3, and a parenthesis because it doesn't include negative infinity. Okay, let's talk a little bit about function notation. Function notation is f of x, right? That's function notation. Negative x squared minus 5x minus 3. That's pretty mellow. And then if I say f of negative 1, that means you're replacing any place you see an x, you're replacing it with negative 1. Now, my recommendation, when I teach this to even my Algebra 1 kids, I tell them to replace the x's with parentheses. So, do this. Okay? I think it's so much easier because, especially this problem that I gave you right now, I've got a negative 1. It's so easy to put a negative and then double negative 1 and then it's positive, and that's not true. Okay? Because you guys know your order of operation. You always do your exponent first. So this becomes 1 and then it's negative 1. That becomes plus 5 and minus 3. So negative 1 plus 5 is 4. 4 minus 3 is 1. That's your answer to that problem. Okay, so that's important. Replace those variables with parentheses. Okay, let's try another one here. F of x minus 3. Well, here, I need to write this out here again. This is my original problem. So f of x equals negative x squared minus 5x minus 3. So f of x minus 3 is negative x minus 3 squared minus 5 times x minus 3 minus 3. Okay, so, just do your distributing first. Obviously, you got to write it twice. Don't forget that. And you're going to get negative, and then you get x squared minus 6x plus 9 minus 5x plus 15 minus 3. And so you get negative x squared plus 6x minus 9 minus 5x plus 15 minus 3. So your final answer, you get negative x squared, 6x minus 5x, x, plus x, and then negative 9 minus, or plus 15 minus 3 is plus 3. Okay, that's your answer. All right, let me draw a quick graph here. So if I draw a graph like this, okay, and I said what is f of 3? Well, I just go to this. Remember, that's saying, hey, when x is 3, what's y? So when x equals 3, what is y? Which is the same thing as f of x. Okay, so x is 3, 1, 2, 3. I guess we'll do 4. Okay, 1, 2, 3, 4. Y is 2. It's pretty easy. Okay, if I told you f of x equals 0, and then I would ask you what is, what's x equal to? So let me make a couple more marks here. When f of x equals 0, so I'm saying when y is 0, what's x? Well, isn't it two values? X is going to be 1, and x is going to be negative 2. Okay? That's pretty easy. Okay. And I'll just write this out, right? X comma y is the same thing as x comma f of x. Those are identical. X and f of x are interchangeable. Okay, let's talk about domain and range. So first let's talk about a function here. And remember, a function is, if it's a graph, you can do the vertical line test. Okay, and if you just look at it, the x values can't repeat. Okay, which kind of makes sense. I mean, if I just did a quick graph here, and I had something like that, And I said, is that a function? Well, of course it's not, because you can do vertical line tests and you hit it more than one spot each time you draw a vertical line here. And then, of course, the x value repeats too, right? Because isn't this 0, comma 2, and isn't this 0, comma negative 2? So there you go. X value is repeated, so this is not a function. Okay, so let's go back to domain and range. Let's write this out again. Domain and range. Okay, domain is acceptable values of x, and its range is acceptable values of y. And again, don't get that confused, right? The way I remember it is d comes before r and x comes before y. So the d goes to the x, r goes to the y. Dr. XY. Ooh, he's very scary. So let's do a domain range here. If I gave you y equals 2x plus 3, and I say, what's the domain? Well, it's acceptable values of x. Well, what can x be? There's no restriction here, right? X can be anything. So it's negative infinity to infinity. And what's the range? Well, there's no values. I mean, it's any value here too, so it's also negative infinity to infinity. That's pretty easy. What about y equals x squared plus 4? Well, can't x be anything again? Sure, there's no restriction. Negative infinity to infinity. The range, now that's a different story. Think about it. This value here can never be negative. But what's the smallest value can be? Can it be 0? So that means if that's 0, then this whole thing goes to 4. So the smallest value this thing can be is 4. And the biggest it can go to infinity. Now, is that right? Not 100%. Why? Because can't it equal 4? Okay, so it's a bracket with a 4. All right, and let's do another one here. Y equals negative x squared plus 4. So again, the domain can be anything, right? There's no restriction. X can be anything. So negative infinity to infinity. And the range, now, the smallest value, again, it can be 0 for x, right? And then it goes to, you get 4. And then as the numbers get bigger, doesn't it get less and less and less? So isn't this going to be on this side 4? That's the biggest value you can get. And what's the smallest value? Well, it can go down to negative infinity, right? So negative infinity to 4. And just remember, math fans, like this first equation, isn't that just a parabola? And that parabola, the vertex, is going to be, well, think about it now. It's 4 comma, right? The 4 to infinity is the range. So isn't the vertex going to be 0 comma 4? So that's the vertex right there. And then the graph is going to look like this. Okay? Pretty mellow. And the same thing, that one, this next equation, except this one is just going to go down from the same spot. Oops. From the same spot. It went down. So that one's negative infinity up to 4. All right, that's pretty mellow. What about this one? Y equals 2 over x plus 3. What's the domain? What are acceptable values of x? Well, there's a little restriction now, right? Because that denominator can't be 0. So that means we're going to talk about graphing a lot in calculus. So where is it equal to 0? Well, isn't it at negative 3? So really, the domain is from negative infinity to 3, or to negative 3, union negative 3 to infinity. It's everything but 3, and that's what this says. Because remember, that means not including. Okay? So that's the domain. What about the range? What can the range be? Well, again, kind of think about it. What that denominator can't be what? It can't be 0, right? So this can't be 0 either. So basically what you're doing is you're saying it's between negative infinity and 0, union 0 and infinity. 0. It just can't be 0. That's what that whole function can't be 0. All right. And let's do one more here. What if I just give you guys a graph? And let's say 1, 2, 3, and 1, 2, 3, 4, and 1, 2 up this way, 1, 2 down here, and let's just kind of go. We'll go over here, -3. So this is your graph. You want to write that in your paper. Pause it if you want. Okay, but I get something that looks like this. Okay, that's not a great graph, but let's look at the domain. Notice, math fans, there are no arrows. Okay? So that means the domain are acceptable values of x. So here it gets down to x equals -3 here, and it gets up to 1, 2, 3, +4. So between -3 and 4, that's the domain. Okay, and the range is minimum value of y, which is -3, and the maximum value is both these points here, right there and there, and it's 2, and that would be your range. Okay, so that's it for day 1. If you're watching this video tomorrow, you're going to need to bring your TI graphing calculator. And at the time of making this video, the best one here is the TI-84 Plus. And some people have the silver edition. If you have the diamond edition, you want to definitely bring that. I don't actually think there is a diamond edition, but I'm just saying that. Okay, that's it, math fans. Hope you all, well, I hope you didn't learn too much. I hope you actually remembered a lot of the stuff that I just showed you. All right, that's it, math fans. Have a good day. Goodbye.